So introduction to factoring. Before we start learning how to factor, the first thing we're going to go over is how to find the GCF. So the GCF is the greatest common factor, which is the largest factor that the terms have in common. So largest factor that they have in common. We're going to find the GCF by using the prime factor tree. So remember, the prime factor tree is dividing into these numbers only using prime numbers. Okay, so similar to what we did previous notes. So looking at example 1, it wants us to find the GCF between 24 and 36. So what we're going to do is we're going to do the factored tree for 24 and then the factored tree for 36. Okay. So for 24, what's the first prime number that can go into it?
2 and 12.
Good, so we'll get 2 and then 12. And then for 12, 2 works again and we get 6. What about for 6?
2 and 3.
Good, 2 and 3. And then we stop here because we ended on 2 prime numbers. Okay. Now we're going to do the same thing for 36. So again, 2 can go into 36 18 times. 2 can go into 18 9 times. And what can go into 9? Good, 3 and 3. And we ended on prime numbers. So if we were to write this out, we have that 24 is equal to all of those prime numbers multiplied together. So 2 times 2 times 2 times 3. I took all those prime numbers attached to 24 that we circled. For 36, we have 2 times 2 times 3 times 3. Again, all those prime numbers that we circled. So in order to find the GCF, we have to circle what they each have in common. So they both have 2's. They both have another set of 2's. Do they have a third set of 2's?
No.
No, but what else do they have in common?
3's.
The 3's. So that means that the GCF is going to be all those numbers multiplied together. So just 2 times 2 times 3. So I took 1 from each pair. And 2 times 2 times 3 gives us 12. So what this tells us is that 12 is the largest number that can divide into both 24 and 36. And for these smaller numbers, it is easiest to figure out that in your head, figure out what's the largest one can divide into both. But when we have larger numbers, it's not as easy. So that's why we always use the prime factor tree. Okay. Any questions on number 1? Yes.
It's not just on the one, but like, will there be a time where like there is no
GCF?
GCF?
Yeah, GCF?
Correct. There will be a time where there's no GCF. And that's when you do the prime factor tree and they have no numbers in common. Okay. Let's look at number 2. So number 2, we now have 3 numbers that we have to find the GCF from. So that means we're going to do 3 prime factor trees. So going off of 105, can we use the prime number 2? Can 2 go into 105? Nope. So what's the next prime number? 3. 3 goes into 105 35 times. What prime number goes into 35? 5. And then we're left with 7. Is 7 prime?
Yes.
Okay, so that means we're done with 105. Okay. Let's look at 40. What prime number goes into 40?
2.
2, and we're left with 20. 2 goes in again, and we're left with 10. What goes into 10?
2 and 5.
2 and 5, both prime?
Yes.
Okay. Now we do 60. So 2 goes into 60 30 times. 2 goes into 30 15 times. What goes into 15?
3 and 5.
3 and 5. Both prime. Okay. So now what I'm going to do is I'm going to write this out so we know that 105 is equal to 3 times 5 times 7. All those prime numbers. 40 is equal to 2 times 2 times 2 times 5. Again, I'm just writing all the prime numbers that I circled. And 60 is equal to 2 times 2 times 3 times 5. So looking at all three numbers, what's the only number they have in common?
5.
The 5. So that means the GCF for this problem is what? 5. That's the only number they had in common. If they had another number in common, we would just multiply those numbers together.
Oh, so because 105 doesn't have 2, it makes it not part of it.
Correct.
Okay.
Correct. If it would have had a 2, then we would also take out a 2, and we would do 2 times 5, so the GCF would be 10. So it's whatever they have in common. Okay. Go ahead and take a moment and try 3. So you're finding the GCF between 12 and 20. Remember, once you have your prime factor trees, you're seeing what prime numbers they have in common. You're multiplying them together to find the GCF. Okay, I'm going to start doing the prime factor trees for each. You continue working if you're still solving the problem. Okay, your prime factor trees for 12 should be 2 and 6, and then you end in 2 and 3. And then for 20 should be 2 and 10, and then you end in 2 and 5. Meaning 12 is 2 times 2 times 3. 20 is 2 times 2 times 5. So you guys found that the GCF is what number?
4.
4. GCF is 4 because they have 2 pairs of 2's in common. So 2 times 2 is 4. Okay. Let's go ahead and look at number 4. Go ahead and do your prime factor trees for 45, 75, and 30. So you're doing 3 factor trees. Remember, if 2 doesn't work, you go on to 3. If 3 doesn't work, you go on to 5. Okay, I'm going to start doing the factor trees. If you're still working, continue working. Okay, so these are the prime factor trees you should have got. For 45, it should have been 3, then 15, ending in 3 and 5. For 75, you got 3 and 25, ending in 5 and 5. And for 30, 2 and 15, ending in 3 and 5. So that means 45 gives us 3 times 3 times 5. 75 gives us 3 times 5 times 5. And 30 gives us 2 times 3 times 5. So knowing this, what's the GCF that you guys got?
15.
15, correct. 15 because they all have a 3 in common, and they all have a 5 in common. So 3 times 5 gives us 15. Which means 15 is the largest number that can divide into 45, 75, and 30. Any questions about GCF for just the numbers?
They don't
Yes.
have to be in like the straight row. They can be just as long as they all have.
Yeah,
same number.
as long as they have the same. Just remember in multiplication, I could have technically wrote this as 3 times 2 times 5, and then they all would have been in the same place. As long as they have a matching pair. Okay, so now looking at the rest of these problems, not only do we have numbers, we now have our variables. So that means when we're finding the GCF, we're going to find the GCF of the numbers first, and then we're going to find the GCF of the variables. So right now, just focusing on the numbers. So 7, 14, and 21. Okay. We could do a, sorry?
You said first we're finding the numbers.
Yes, first finding the GCF of just the numbers. So we could do the prime factor tree for each of these, or since the numbers are small, what's the largest number that can divide into 7, 14, and 21?
7.
7, so that's the GCF. So the GCF, starting out just for the numbers, is 7. Now we're going to look at the variables. And how we find the GCF of the variables is we find, again, what they have in common. And what they all have in common is going to be the smallest of all the variables. So which one's the smallest here?
2.
X squared. So x squared is the GCF for the variables. Once we find the GCF for both, we just combine them to find the total GCF, and that GCF is going to be what? Yep, 7x squared.
You said that the greatest common factor for variables is the smallest one?
Correct. And I'll write that over here. Smallest they have in common. Oops. Let me also draw a visual over here so you could see. So x cubed is the same as x how many times? X times x times x, so it's 3 times. X squared is x how many times? 2 times, and x to the 4th is x how many times? 4 times. So that means the amount of x's they can have in common is that lowest number. They can only have 2 in common. That's why our GCF was x squared. So you could think of it like this and use this visual and write out how many of each variable and find the ones in common. Or you could just remember that it's always the smallest one. So let's look at number 6. So in number 6, how many variables do we have? So we have 2 variables now instead of 1. So we're going to do the same thing. We're going to do the numbers, and then we'll do the variable A, and then we'll do the variable B. So starting off with just the numbers, we have 15 and 25. What's the largest number that can divide into 15 and 25?
3 and 5.
Well,
Sorry.
for 5, right? So it's the largest number that can go into 15 and 25 is 5. Okay, since they're smaller numbers, we're doing this part in our head. Or you could do the prime factor tree and you would still get 5. Okay. Now we're looking at just the A's. So we have A to the 4th and A to the 3rd. What's the GCF of the A's?
8, 3.
Yep, A to the 3rd. It's always the smallest. Okay, now we're looking at the B's. What's the GCF for the B's?
B.
Just B, because it's whatever's smaller. Okay, so putting this all together, that means the GCF for this answer, or for this problem, is what?
5A, 3B.
Correct. Phi A cubed B.
It's not too bad. Until it is.
Okay, go ahead and try 7 on your own. You're doing the numbers, then you're going to do the Z's. Remember, if you can't think of the GCF for the numbers on the top of your head, do the factor tree. Yes?
If we can think of it, do we have to do the factor tree regardless on the test?
Good question.
Like,
If I give you numbers like 123 and 154, I can't do that in my head, so I would want to see some work. If numbers like this, 10, 15, 40, that's fine. Small numbers. 2-digit numbers, I don't got to see it. 3-digit, that's what I'm going to kind of doubt a bit. But these problems are kind of hard to show work, so as long as you're getting that correct answer. So what'd you guys get for the GCF of 10, 15, and 40? 5. So 5 is the largest number that can go into those numbers. What about for Z to the 3rd, Z to the 5th, and Z?
Z.
Z, good. It's whatever is the smallest. So that means our GCF for this problem is what? 5Z. Go ahead and try 8. So you're just going to have one more step because there's one more variable. Okay, so what's the GCF you got for 6 and 21?
3.
3, so GCF for the first part's 3. What about for the W's? W3, because it's the smallest. And what about the Y's? Y to the 5th or Y squared?
Y squared.
Y squared, because it's the smallest. So that means the GCF for the entire problem was... Good, all of those next to each other. 3W cubed, Y squared. Okay. Let's look at number 9. Number 9, how many variables do we have? We have 3. However, look at that second part. Does that have that third variable? So what do you think that tells you about the variable e? Is it going to have a GCF? No, because they both don't have at least one e. So that means we can ignore the e because the e is not going to be part of our answer because they both don't have the e. So, focusing on just the numbers, what's the GCF of 8 and 6? 2. Good. So, the first part, GCF is 2. What about the C's?
C squared.
Good. C squared. What about the D's?
D4.
D to the 4th. And again, we're ignoring E. Why are we ignoring E? Good, because the other part that we're comparing it to does not have an E. So that means the GCF for this problem is what? Good, 2C squared, D to the 4th. They both have to at least have one of those components in order to find the GCF from them. Okay. How many variables are in number 10? 4?
2.
2? No, it's more than 2.
4. Wait.
There's 3. There's M, N, and P. However, does the second component have an M?
No.
So what are we going to do with the M's?
Ignore it.
Ignore it. Okay. So first, starting off with just our numbers, what's the GCF of 9 and 15? 3. Skipping the M's because the other one does not have any M's. What is the GCF of N and N to the 4th? Good, N, because it's always the smallest. And then lastly, what's the GCF of P to the 8th and P to the 5th? P to the 5th. So that means our overall GCF is what? Good, 3NP to the 5th. Okay. Now looking at number 11. What's different about number 11 than the rest? Yes.
To go back to the last one.
Yes.
When we're looking at the variables like N and P,
Uh-huh.
I was thinking that they were together as like one unit. Like NP and then there's N and P. Do we know?
Oh, I see. The only way they would be together if they were in parentheses.
Okay.
See, and that's why I said 4.
Yeah.
Because I thought it was M, NP, N by itself, P by itself. That's why I had said those 4 variables. But, okay.
Oh, I see.
Yeah.
Yeah. Yeah, it's not next to each other. If it was in parentheses, NP in parentheses raised to the 8th, then it's one variable. This was just an example where the n didn't have an exponent.
Yeah.
Okay, great question. Now on number 11, notice how we have parentheses here. So if we're comparing the variables now, how many variables do we have? Because A and B is in parentheses, that means we count it as 1. So we only, well, we still have 3. You're right, we have 3. Because we have x, we have that variable A plus B, and then in the next one we have a y. However, are we going to have a GCF for x and y? No, because it's not in both. So we're ignoring the x and then ignoring the y. Looking at the numbers, would we have a GCF for 3 and 2? No, because there's not a number that can divide in both 3 and 2. I mean, that number is technically 1, but we don't need to write the GCF of 1 because that doesn't change our problem. So what's the only thing they both have in common? A plus B. So that means the GCF has to be A plus B. That's it. So we looked at the numbers. We ignored x and y because they both don't have it. The only thing they had in common was that A plus B. So knowing that, what would be the GCF of 12?
X plus 2.
X plus 2. We had no numbers to compare, and the only other variables were A and B, which we would ignore because they both don't have A and B. So any questions over that first concept? That was just learning how to find the GCF. Okay? Remember, always break it down. Now we're going to use that GCF and we're going to start factoring. So in the next examples, not only are we going to find the GCF, we're going to factor that out of our problem. So looking at number 13, what is the GCF? 4. Why is it just 4? Good, they both don't have an x, so we can't have a GCF for that variable. And the only numbers we're looking at are 4 and 20. And the largest number that can divide into 4 and 20 is 4. So once we find the GCF, we're going to write that GCF on the outside of parentheses. Okay. And in order to factor out that GCF, we're going to take every term and divide it by that 4. So for example, we're going to do 4x divided by 4. What do we get when we do that? 1x, or we could just write x. Then we're going to do the next term, negative 20 divided by 4.
5. Negative 5.
Negative 5. So this is our answer. 4 times parentheses x minus 5. Okay. We could always check our work to make sure we are correct. We would check our work by distributing the 4 back into the parentheses. And we should end up with our original problem, which we do. So if you're ever not sure, you can check your work. Okay? Now looking at 14, what's the GCF of the problem? 3W. Good, because the GCF of 6 and 3 is 3. And the smallest from W squared and W is W. So GCF is 3W. What do we do with that GCF once we find it? Put it outside parentheses. And then what are we doing with that 3W? Dividing. So we look at this first term. 6W squared divided by 3W. Good, it's going to be 2W. So you do the numbers. 6 divided by 3, you get 2. And W squared divided by W is just W, because we're taking one of those W's away. So this is 2W. And then what's 3W divided by 3W? 1, because 3 divided by 3 cancels, that's 1. W divided by W cancels, that's 1. So it is plus 1.
So the W's cancel out.
Correct. And again, you can check this by distributing. So if you distribute that 3W back inside, you're going to get that 6W squared plus 3W. So again, if you're ever not sure, check your work. Okay. Go ahead and try 15. Find your GCF and then factor out that GCF. When you get to the answer, just check your work to verify. So for 6W plus 18, what's the GCF you guys got?
3.
Good, it should have been 6 because 6 is the largest number that can go into 6 and 18. Okay, so GCF is 6. So if I take that 6 and put my parentheses, what is 6W divided by 6? W, because the 6's cancel. And what's 18 divided by 6? 3. So W plus 3. Again, checking your work. If we distribute that 6 back inside, we would get our original problem of 6W plus 18. So you know you found the correct GCF. When you look at what you get inside the parentheses, you can no longer take a GCF out. So from W and 3, we can't take a GCF out, so that's how I know that I found the correct GCF. If you would have picked the GCF 3, you would have noticed that inside of here, you would still have something else you could take out. For example, if you took out the GCF 3, you should have had 2W plus 6. Notice how that 2W plus 6 still can take out a 2. So that's how you know you didn't get the highest GCF. Okay. Okay, go ahead and try 16. So what's the GCF that you guys got?
7.
7m. Good. GCF 7m. Because between 21 and 7, we can take out a 7. Between m cubed and m, we can only take out 1m. So if I have 7m, I do my parentheses, and I start dividing. So what's 21m cubed divided by 7m? Good, 3m squared, because 21 divided by 7 is 3. M cubed divided by m means we only get rid of one m, so it turns to m squared. So this is 3m squared. And then what's negative 7m divided by 7m? Negative 1, because the 7's will cancel and the m's will cancel. So negative 1. Again, we could check our work by distributing that 7m back inside. Any confusion when we're dividing variables? A little bit? Okay. So I'm going to go ahead before we do 17. Off to the side, I'm going to write the properties of exponents. We don't go over this too much in this course because this is something that they assume you already know. So properties of exponents, how I'm able to do that so quick is because I know if I multiply two bases, so two similar bases that have different exponents, for example, y squared times y to the 5th, that becomes y to the 2 plus 5, which is y to the 7th. So when I multiply the two components that have exponents, I add the exponents. The important part here is the divide part. If I divide, for example, y to the 5th divided by y squared, that's kind of what we're doing here when we divide them to find our factor. Instead of adding them, I subtract them. So this is y to the 5 minus 2, which is y to the 3rd. So that's what I did in the part above when I had...
No, the 3 minus 1 is the 2. That's how you got 3 and 2. 3 squared.
Correct. Yeah, so when I had that m cubed divided by m, that's the same as saying m cubed minus 1, because there's a 1 here, m squared. So again, just use this as just knowledge for the rest of the notes.
Can you add, what is it, when it has two different exponents? Like y2 plus y1 cubed?
If the problem's like this,
Yes.
no. If it's y squared plus y cubed, that means they are not like terms, so we have to leave them the same. Only if they're being multiplied or if they're being divided. That's it, the only two options. Okay. So looking at number 17, we have our numbers 15 and 12. Between 15 and 12, what's the GCF of just the numbers? 3. Then we have y cubed and y to the 4th. What's the GCF between those y's? Y cubed. Remember, it's always the smallest one. We don't start subtracting till we factor. So if I take that 3y cubed, put it outside of parentheses and start dividing, what's 15y cubed divided by 3y cubed?
5y.
Just 5 because y cubed
cancel out.
divided by y cubed cancel. Good, so just 5. Now 12y to the 4th divided by 3y cubed.
4y.
4y. Good, because that y to the 4th divided by y to the 3rd is just y. So it means this is my answer. Okay. On number 18, we now have 3 terms that we're comparing to find the GCF. Okay. Notice they all have a number, they all have A's, and they all have B's. So that means our GCF is going to contain each of those components. Okay. So looking at 9, 18, and 27, what's the GCF between those numbers?
9.
Good, 9, because 9 is the largest number that can divide into all 3. What about the A's?
A4.
A4, because it's always the smallest. And what about the B's? B. Okay. So I'm going to take 9a to the 4th b, write it outside parentheses, and I'm going to do each one dividing. So what's 9a to the 4th b divided by 9a to the 4th b?
9. Oh, 1.
1. Good, because they all cancel out, so 1. Now I have negative 18a to the 5th b divided by 9a to the 4th b.
Negative 2a.
Negative 2a. Good, because the b's cancel. And then lastly, I have 27a to the 6th b divided by 9a to the 4th b.
Plus 2 squared.
3a squared. Correct. So we do the numbers, then each of the variables. So plus 3a squared. Okay. That is our answer.
Yeah, that property of exponents helped me a lot.
Okay. Because you guys learned that in Math 0320, but I know some of you were able to skip that course. Yeah. Okay, number 19. What's the GCF of the problem? Good, 3y squared, because 3 is the largest number that can go into 9 and 6, and y squared is the smallest of those y's. So dividing, what's 9y squared divided by 3y squared? 3, because the y squareds cancel. And what's negative 6y to the 5th divided by 3y squared?
Negative 2.
Negative 2. What about our y's? Y cubed. Perfect. Negative 2y cubed. Because it's y to the 5th divided by y squared. Means we do 5 minus 2. And we get 3. So this is our answer. Okay. Go ahead and try 20 on your own. Find the GCF and then factor it out. Okay, what'd you guys get for the GCF? Good, 10 ST, because between 50, 40, and 10, the largest number we can divide into all three is 10. Looking at the S's, the smallest one we have is just S, and same with the T. So if we take 10 ST and start dividing that in, what did you get when you did 50 S cubed T divided by 10 ST?
Minus squared.
Good. 5s squared because the t's cancel. Okay. What about when you did negative 40 st squared divided by 10 st?
Minus 14.
Minus 4t. Correct, because the x's canceled. S's, not x's. And then 10 st divided by 10 st.
Plus 1.
Good. 1. That's your answer. Okay. So for those problems, we had to find the GCF before we factored. In the next couple problems, they are going to give us the GCF. So for example, in 21, they give us the GCF of negative 3. And it wants us to factor it out. So that means right away we're putting that negative 3 on the outside of our parentheses. And then we're going to start doing what? Dividing. So they just did a step for us here. So looking at the first part, what would be negative 3x squared divided by negative 3? Good, x squared, because the negative 3's cancel, and we're just left with x squared. Or you could write 1x squared, but we don't need to. Just x squared. Okay. What about 6x divided by negative 3? Good, negative 2x. The only thing that is happening here is just reducing the numbers, because we're not taking out a variable here. We just took out a negative 3. So just reducing the numbers. So what's negative 33 divided by negative 3?
Plus 11.
Plus 11. That's our answer. And again, we can check by distributing that negative 3 back in, and we should get our original problem. Any questions on these ones where they give you the GCF? Go ahead and try 22. So our GCF here is what? Negative 2. So you are dividing out a negative 2. So that means the only thing that's getting affected is the numbers. Just the numbers. Okay, so when you took out a negative 2, what did we get for the first term? X squared, because negative 2x squared divided by negative 2, those negative 2's cancel. What about for the next term?
Plus 5.
5x. So right here, that negative 10x and that negative 2, only the number is getting affected. So negative 10 divided by negative 2 is 5, and we bring the x down. What about the last term? Negative 8. Because 16 divided by negative 2 is negative 8. (21) and 22 are simple because we're just taking out a number. Okay. But on 23 and 24, our GCF now contains variables. So here, our GCF is that negative 4PQ. So I'm going to write that negative 4PQ on the outside, draw my parentheses, and I'm going to start dividing. So looking at just the first term here, what is negative 12P cubed Q divided by negative 4PQ? 3P squared. Good. Look at each component. So negative 12 divided by negative 4 is 3. P cubed divided by P is P squared. And Q divided by Q cancel. So that's our first term. What about for our second term? 2PQ. Good, because when we divide P squared by P and Q squared by Q, we're left with just one of each. So we have plus 2PQ. And then lastly, what do we get when we divide with the last term? Negative Q squared. Good. Okay. We don't need to write that 1 there. Okay, if we write a 1, it does nothing for our problem. If we don't see a number in front of our variable, we always assume it's 1. Okay. So for these ones, not only were we dividing out the numbers, we are dividing out the corresponding variables. Go ahead and try 24. Here your GCF is negative 5xy. And this is exactly how it would look on an exam with the exact wording and everything. Okay, so I take my GCF, I write it on the outside. What'd you guys get when you divided into the first term? 2x, correct, because the y's cancel out. 2x. Okay, what about when you divided into the second term? Minus 1, because of that negative here. Minus 1. And then the third term?
Plus 3y.
Good, plus 3y, because the x is canceled out. Okay, and again, we could check our work by distributing that negative 5xy into the entire problem, and we should end up with our original question. Okay, so any questions on this concept? This concept was factoring out a GCF. So now that we learned how to find the GCF and how to factor it out, we are going to learn how to factor. So this factoring method is called factor by grouping. You always know that you're going to be using factor by grouping as if you have 4 terms. So I'm going to write that here. 4 terms. Okay. If you do not have 4 terms, you cannot do factor by grouping. Okay. So all of these examples are going to have 4 terms. Remember, the terms are separated by an operation. So this is 1, 2, 3, 4 terms. All separated by a plus sign in this case. The reason this is called factor by grouping is you're going to group the first 2 terms. Okay. And then we're going to group the last 2 terms. And what we're going to do with each of those groups is we're going to find the GCF of the first group and then the GCF of the second group. So looking at only this first group, so this 3AX plus 12A, what would be the GCF for that? 3A. So I'm just going to write 3A parentheses. Okay. And before I divide into that, I'm going to find the GCF of the next parentheses set. What would be the GCF for 2BX plus 8B? 2B. Parenthesis. Okay. Now I'm going to start dividing everything out. So looking at the first one, what is 3AX divided by 3A? X. And then what about 12A divided by 3A? 4, because the A's cancel. Looking at the next parenthesis, what's 2BX divided by 2B? Good, just X. And then lastly, 8B divided by 2B. 4. What do you notice about both of these parentheses? They're exactly the same. That's what we want. If you ever start doing factor by grouping and you do not get the same parentheses, so this part and this part, you did something wrong. These will always be the same. Okay. From here, so from this step here, we are now going to factor out what they both have in common. And we just said they both have what in common? X plus 4. So I'm going to write X plus 4 in one set of parentheses. And then the next set of parentheses is going to be whatever is left on the outside. So what's on the outside of each of these parentheses? 3A plus 2B. I know it's plus 2B because 2B is positive. Okay, this is our answer.
And what is this called again?
Factor by grouping.
So inside the parentheses, you put what's in common.
Correct. Correct.
In the first set of parentheses, sorry.
Yes.
And like the right answer will always have the same matching.
Always. Always. If there's ever a time where you can't get it to match, then we would say that the answer is not factorable. Okay? In these problems, you're not going to get that. So again, this is just another skill we're learning to apply to the big skill. We haven't even got to the big skill yet. These are just the little skills. I believe next notes is the big skill. Okay. Okay, so 26. Again, we know we're doing factor by grouping because we have how many terms? 4 terms. So we group the first 2 and then the last 2. Once we group them, what's our next step? Good. Find the GCF of each parenthesis. So what would be the GCF of the first one? 5. What about the GCF of the second one? 8, because it's the only thing they have in common. Okay. So that means when I divide that first parentheses by 5 and I divide that second parentheses by A, my 2 parentheses should what? Match. Okay, so let's go ahead and do the first one. What's 5x divided by 5? X. What's 10y divided by 5? 2y. Next part. What's AX divided by A? What's 2AY divided by A? Did we get the same? That means we did it correctly. Okay. So that means my answer here is going to be always the parentheses they have in common. So X plus 2Y. And what's my next parenthesis? 5 plus A, because it's whatever's on the outside. So a 5 was left and an A was left. So our GCFs. And that's our answer.
Sorry.
Any questions on that? Okay. Let's look at 27. So our first step is to do what? Group it. So the first two, the last two.
It's on negatives, do we include that second negative?
Correct.
And we don't include the positive?
Correct. So notice I mean, I did it in this one where I included the positive, but you really don't need to include the positive because it's not going to change your answer. And this positive right here is what I'm talking about. However, when you have negatives, you have to include that sign because that's going to affect your GCF when you take it out. Okay, once we group, what's our next step?
GCF.
GCF. What's the GCF of the first one? A. Good. Because AX and AY, the only thing they have in common is an A. What about the next one?
-1.
-1. And that's why it's important to include that negative. Okay? So if I take out an A from the first parentheses, what do I have left when I divide? X plus Y, because AX divided by A is X, AY divided by A is Y. And the next one, if I take out a -1, what am I left with? X plus Y. Do they match?
Yes.
Okay, so that means my answer is what? Perfect. X plus Y, and then A minus 1. So whatever they have in common, and then whatever was left on the outside.
Now, you said that, in this case, it's not gonna be non-factorable. Is it safe to say that we could just write that first part into the second part without having to do the math, or? You might be able to
In this concept of just factor by grouping, there's never going to be a part where they wouldn't match. However, I wouldn't rely on writing the same thing again.
Okay.
Because when we talk about the overall concept on Monday, you don't want to get in that habit. Because that next concept, there could be cases where it's not factorable. And if something's not factorable, then we'll learn that we could use the quadratic formula that we learned previous notes. Okay, so our first step is to group. I'm going to include those negatives. What is my GCF of the first one? T, because that's what they both have in common. And before we look at the next one, let's go ahead and divide that T in. So if we divide that first parenthesis by T, what are we left with? U minus V. The only reason I'm doing this first is it's going to help us determine what we should take out from that next parenthesis so it would match. So what would be the GCF we would take out so the parentheses would match? -1. So when we take out a -1, we're left with U minus V. Okay, because when we take out a -1, the signs change. So from -U to positive U, from positive V to negative V, when we took out the negative. Okay, so that means our answer is what? Correct. And that's a great point too. Someone said t minus 1 first. That's correct still. The order of these parentheses that you write them doesn't matter. So you could write t minus 1 and then u minus v. That's the same thing. Because they're being multiplied. And when you multiply two terms, doesn't matter the order. Okay, what's my first step on 29? Group them. Once I group them, I do what? GCF. What's the GCF of 16w to the 4th and negative 40w to the 3rd?
8W.
Good, 8w cubed. Because we look at the numbers 16 and 40, and the biggest number that can go into 16 and 40 is 8. And we look at the smallest of our exponents, which is w cubed. So this is 8w cubed. Okay. Dividing that in, what do we have left in the parentheses? What's 16w to the 4th divided by 8w cubed? 2w. And what about the next term? Negative 40w cubed divided by 8w cubed. Minus 5. Okay. I did that first because I had that negative in the next parenthesis. So usually when you have a negative here, your GCF, you're taking out some type of negative. So either just the negative itself or a negative number. So what would be the GCF between negative 12w squared and 30w? Good, negative 6w, because negative 6 is the biggest that we could take out from negative 12 and 30. And w is the smallest of those exponents. So when we divide negative 12w squared by negative 6w, what do we get? 2w. And 30w divided by negative 6w. Good, negative 5. Do our parentheses match?
Yes.
Yes, so that means our answer is what?
2w minus 5 times 8w cubed minus 6w.
Correct. So whatever matches and then whatever is left on the outside.
But what if you have a GCF on the second parentheses, like the 8w cubed minus 6w?
That is a great point. Thank you, 'cause I would have forgot about that. That's a great point. The point that was brought up, what if we look at that second parentheses and we can still take out a GCF? That tells us that we need to simplify further. So what would be the GCF with that last parenthesis? A 2w. So just looking at this parenthesis here, I can take out a 2w and I'm left with what?
4w squared minus 3.
Good. So that means my answer, my overall answer is going to have all three of these components. So it's going to have that 2w from the outside here, and then the two parentheses, 2w minus 5 and 4w squared minus 3.
Now when we put those two parentheses and parentheses together, or just the w with the 4w?
This is okay because they're all being multiplied.
Okay.
So how did you, I got lost here, I'm sorry. Why did you have to do that?
Because it was brought up that this parenthesis, we could still take a GCF out of. There's still something that we could take out. This concept of going further, so right here, this concept is, we're going to talk about more on the next notes. Okay. So if it's just asking you to factor by grouping, the original answer we got is okay. I wouldn't take off any points. But if the question is to factor, meaning to simplify as much as we can, then the next answer would be the correct one. And again, we're doing that notes on topic 20, which is next. Okay. On the 8th. So I believe that is a week from today. Okay. I have one more, if you guys want to stick around, one more. So if I do the factor by grouping for this one, what's the GCF of that first parenthesis? 3b squared. And then what's the GCF for the next parenthesis? Negative 12b. So if I divide that out, what is 3ab squared divided by 3b squared? Good, just a. And then what's 6b squared divided by 3b squared?
Equals 2.
Plus 2. Next one, what's negative 12ab divided by negative 12b?
8.
A. And what's negative 24b divided by negative 12b?
2.
Plus 2. So meaning when I write my answer, a plus 2 and 3b squared minus 12b, we have another case where I could take out another GCF from that parenthesis. And what would that GCF be? 3b. So if I took out a 3b, I would be left with what? b minus 4, meaning my answer would be 3b times a plus 2 times b minus 4. And I'm doing it in red because this is technically topic 20. And the answer for this one is for today.
How many topics do we cover for the next?
The whole course is 27 topics.
Oh, I mean the upcoming one.
Oh, like for the test? Oh, it's only going to be, I think 15 through 20? Yeah, 15 through 20. Something like that, or 15 through 21. Okay. And then that's it.